This is an instructional video for sand casting process in non-metal mold group. First, execute any pre to set the simulation condition. There are two ways to import STL files. Let's start with the first way. Click File and click Import to import the STL file. Import is a function that loads the saved modeling in STL format into any pre. Another way to import STL files is very simple. Simply just drag the STL file to any pre. Double-click the entity or use that entity to specify inserted, cavity, overflow, and runner. When you simulate a real model of ingate or runner, you can integrate it into runner. Now set mold with set mold. Casting only function is only used for flow analysis without mold, and is not used for general casting. Casting plus mold is used when simulating cavity and mold. When you click the Casting plus mold button, you will see three different options. First of all, box is to create a virtual space. Please input the thickness of each direction. Second of all, shell thickness option will be enabled when you input shell thickness for investment casting. Lastly, mold entity is used when there is mold STL. Made cast from the cavity of mold is a function that recognizes the rest of the mold as cast when there is no cavity but mold data. In other words, if there is cast entity, even when you check this function, simulation will not be proceeded. In this case, since there is no mold entity, we'll create a virtual mold by using box. Select box and enter wall thickness. Set the pour surface based on the axis displayed on the screen. Click Set Domain to set the calculation area. You can adjust the calculation area by using the coordinates and the ratio. And as a result, only the part included in domain will generate mesh. There are three ways to generate mesh, which are build uniform mesh, build variable mesh, and Automatch. First is build variable mesh. Press the spacebar to switch the mode to selection mode. Then select Start and End. After entering dividing number, set the remaining part as autoblock. Mesh will be generated in the orthogonal direction of the selected axis. Set the rest of the Y and Z axis. Mesh generation cannot be executed on the forwarded axis displayed on the screen when generating mesh. After setting X, Y, and Z axis, click OK button to generate mesh. Secondly, we'll look into uniform mesh. In the uniform mesh, there are total number of cells, dividing the simulation area into a fixed size mesh when the number of all cells is input. Also, there is number of cells along axis, which specifies the number of mesh in each axis direction, and size of unicell that specifies one cell size. Size of cell is a function that decides the mesh size of X, Y, and Z directions. The total number of mesh will be generated automatically by the program, based on the values entered by the user. The last one is Automatch. Click Automation. For X, Y, and Z, after setting the minimum and the maximum size of Automatch. Minimum and maximum size as the reference value of the generated mesh size. Let's start with task design. After selecting the process, please select the range of simulation. In the material setting, double-click the entity to select the material. Multiple selections can also be made by pressing the Ctrl or Shift key. Heat transfer coefficient value is input automatically. But please make sure if the value is right or not. The heat transfer coefficient unit of this video is calorie. Please set the pour temperature in gate condition. When setting the gate condition, please switch to mesh mode. Please press the spacebar to switch to selection mode and select the gate. The selected part will be changed to yellow. Then, enter the pour temperature. In the case of sand casting, direct pouring is used since the casting process uses sprue. The center coordinates of sprue will be automatically entered, however, user will need to input the radius of the surface. User will need to input the radius of the pour surface. After inputting the pouring time in flow condition, please click Apply. Then the speed value will be displayed in estimated filling time window. Please input this value in flow condition. To set gravity force, please click Enable and set the gravity direction. The gravity direction is based on the axis displayed on the screen. Gas and melt surface is a function that predicts the amount and the position of the generated gas when melt is poured into the cavity. Oxide slide inclusion model is a function to set oxide occur conditions and to predict oxide dispersion in cavity. After activating it, click the icon next to variable temperature to see the value of the automatic input. The input value should be 0 at solidification temperature of melt material and 1 at pouring temperature. Particle tracing is a function to track the movement path by expressing the melt as particles coming through a gate. Click to enable Start/End control. For particle source value, 10 is recommended. Shrinkage model is a model for predicting solidification shrinkage. Please activate gravity shrinkage since it is a gravity-affected casting due to slow solidifying time. The cast iron module is used when you're using cast iron material. When this function is used, the mechanical properties and phase fraction will be predicted depending on the amount of alloy element. Also, when this option is selected, regardless of the end condition, the simulation will end only after the temperature is cooled until 300 degrees. Please activate mold erosion that predicts the erosion area of mold, as well as core gas that predicts the location of generated gas due to core. However, a core entity should be set in order to use. There are two ways to install a sensor. First is by using a mouse, and the other is by inputting coordinates. Sensor allows you to view speed, pressure, temperature, and etc. in a specific part out of simulation area. After setting in/out condition, click Save, then presetting process will all be done. In general for end condition, please select 100% solidification. However, this can vary depending on the test design setting. When setting is done on AnyPre and the file is saved, 8 files will be created in the folder. If the extension is GSCX, it is the file that contains some contents from AnyPre. MIF6X is virtual mesh information on RealFlow. Therefore, if you delete it, RealFlow will not be applied. MSHX includes physical mesh information. PRPX is a solver execution file. PXM, XML, TXT, and VPX are the files that store information about simulation settings. There are two ways for a simulation. First is save it in AnyPre. And press Run to start simulation. Second is to execute any solver for simulation. After executing any solver, please click Open Project and open the file. Then the information window of space available on disk, space required on disk, and number of resolved files will pop up. Check the information and click Start to initiate simulation. The simulation result can be observed via AnyPost when the simulation is done via AnySolver. There are two ways to run the simulation file. First, execute AnyPost and then click File Open Project to load RLTX file. Second, drag the RLTX file to AnyPost to load the file. Create real shape to map the cap model to the mesh-like result and see it in real shape. However, the real shape only applies to cast entity. In order to observe entity other than the cast entity, you need to deactivate the real shape. The results that can be checked in AnyPost are final result and progress result. In final result, you can observe the changes during the entire simulation process. In progress result, you can observe the temperature, pressure, and speed values set by the user. Final result consists of history data to observe the flow and solidification pattern result. Simple shrinkage analysis to observe temperature gradient and cooling rate. Advanced casting analysis to observe pressure distribution. Microstructure prediction and mechanical properties. Click Filling Sequence in History Data tab to check the filling pattern. You can check the overall filling pattern and the final filling area. You can continuously observe the final solidification time with solidification time. And solidification sequence shows all the solidification process by time, and especially the area where remelting occurs. When observing the solidification pattern, it is recommended to observe an inverse contour. Predict the area where shrinkage defects could occur by focusing on observing the final solidification area in the product. Particle tracing observes filling behavior of melt, showing as particles when filling. Head size is to set the head size of the particle. Tail length is to set the tail length of the particle. Skip factor is to set the density of the particle expression. To observe macro shrinkage, please select Probabilistic Defect Parameter in Advanced Casting Analysis tab. Please select Retain Melt Surface Area in Defect Parameter and use the cross-section view function to observe macro shrinkage inside the product. At this time, the shown shrinkage is a probability distribution, not a size. For micro shrinkage, please select Combined Defect Parameter in Advanced Casting Analysis tab. After selecting Niyama, please select Defect Parameter as Combined Defect Parameter and Probabilistic Defect Parameter and observe micro shrinkage inside the product with cross-section view. In the case of micro shrinkage, user can observe any results by using 3 parameters. At this time, the shown shrinkage is a probability distribution, not a size. In Microstructure Prediction, graphite, carbide, ferrite, pearlite, and nodule count will be only displayed when cast iron function is used in any pre. Use cross-section view to observe. Mechanical properties are displayed only when cast iron is used in any pre. For gray cast iron, only Brinell hardness and tensile strength are shown. In ductile cast iron, yield strength and elongation will be added and displayed. Use cross-section view to observe. Progress result shows the result depending on output condition step that user set in any pre. User can select and observe specific result out of temperature, pressure, velocity, gauge flow tracking, viscosity, and gas entrapment. Temperature is melt temperature during filling and solidification. Progress result shows the result depending on output condition step that user set in any pre. Velocity is speed of melt during filling. In core gas result, there is core gas in cast that allows you to observe the gas remained area in cavity, and core gas out core that allows you to observe where the gas is generated in core. Use cross-section view to observe. Please refer to user manual for fine adjustment or data export when observing other results.